Hello, everybody, and welcome to today's customer enablement session. Our presenter today is Dr. Michael Ali, Saratech's Senior Vice President of Engineering Operations. Those of you who were on our last MBSE session will recognize Mike. Today, Mike's going to be talking about the top 5 ways to get started with MBSE.
Okay, hello
Yep.
everybody, and thanks for joining us for this session. Just a reminder, right? We've got a viewpoint in MBSE, and we're really here to help people who want to get started with this, who want to help their companies use it. We think it's a valuable tool for engineers and engineering departments to be using in product development. So you're going to learn how to put MBSE in the context of SE, because that's important. And probably a big theme that you'll hear over and over again is why it's a change leadership initiative. It's not enough to think of MBSE as just sort of another tool. You'll do some training. It really does involve change leadership to make it effective. And how to get quick wins when you're going through that process of introducing MBSE and why that's important. If you're someone that's interested in MBSE and how to deploy it, whether you're an engineer or a manager, this talk will help you. If you're a team that's been told, hey, we've got this MBSE that we want everybody to start using, and you're trying to figure out what it is, and maybe you've been told that you have some deliverables that you have to create, but you're trying to figure out what the value is and maybe provide feedback on some ideas of where the value is for you in MBSE, this will help you. And as far as tools, just note that we're going to be talking about tools on a very limited basis. And really, it's more about why you shouldn't start by selecting a tool as the way to get started with MBSE. And we'll have plenty of time for questions, like I said, at the end. So let's do a level set, though. What is MBSE, what it is, and why do it? So let's say, first of all, before you can talk about MBSE again, you got to talk about systems engineering. And let's just take a simple test, right? A farmer needs a better way to treat their fields. Tractors, planes, helicopters all have trade-offs. The farmer thinks that maybe unmanned aerial vehicles could help them out, but which one? And there's different configurations, right? There's sort of the winged helicopter, there's the quadcopter, and a basic airplane configuration. And what I found when I ask people this question, like I'll ask an audience this question, I'll get people immediately saying, oh, it's the one on the left, or it's one on the right, or one in the middle, whichever one. And this is the difference between a systems engineer and everyone else. A system engineer would say, it depends. I don't know the right answer until you tell me A, what the farmer's requirements are, and B, how to map those onto the UAV specifications. So when I know that, then I can say which one's the right answer. And that's why system engineering is really defined as the engineering discipline that enables the successful realization, use, and retirement of systems that meet requirements. And one of my mentors early in my career, Dave Oliver, who's an NCOSE fellow, once said, the first rule of system engineering is specify what you want or take what you get. And the way it's captured is in this traditional V model where you go from concept through a system level design to subsystem to detailed design, build, test, validation, and deployment. And traditionally, system engineering has been document-based. All the steps in that V are basically managed by generating a bunch of different documents that are then controlled and moved around the system, the department, people, as you go through the various stages. And what's happened over time is that the complexity of modern day systems and the rise of computer-aided everything, computer-aided design, computer-aided manufacturing, computer-aided engineering, et cetera, is driving the move from documents to models. And by that, it means that instead of these documents sort of being the core of the process, you now have a model repository that gives you consistency and validation through every step of that process. And so NCOSE has actually codified that into a definition of model-based system engineering as the formalized application of modeling to support requirements, design, analysis, verification, and validation activities through, again, all the life cycles of product development. And this shouldn't be a stretch for engineers because we already generate diagrams, models with useful information. So this is a very simple example. On the right, it's a spacecraft. you can immediately see that it's got different subsystems: guidance, navigation, control, propulsion, avionics. You can see some of the interfaces because you see how these things are connected. You see data moving between guidance, navigation, control, and the data handling subsystem. You see some of the nature of those interfaces. You even see some of the types of data there. And also there's even a scenario. So that blue line actually shows how you'd go through the system being commanded to start collecting data from a payload sensor and then pulling that back out and sending it back to Earth. So you can capture a lot of information in these diagrams and models. And I would always say, I can't even fathom how someone could capture what I just said in text. You really want a diagram. You already have it. Why not use it? And the nice thing about model-based system engineering, it says, great, you're doing these things. Let's let the underlying data model be the master. So as you pull these things together, there will be an underlying data model that will become the master. And then you just think of text or diagrams as views of that data. And again, you get consistency, you get change control, you get a bunch of things because now everybody's working inside against this master data model, and you get whatever output you want. And it's not that one output is necessarily better than another. It's that now you're driving everything from the model, and that's the ultimate goal. Now, when it comes to introducing MBSE, you'd be surprised that you get excited. You got this great new tool, and you show it to people. And unfortunately, it's not. If you create a better mousetrap, the world beats a path to your door. A lot of times, the world is very busy. A lot of times, they think they have a good mousetrap. It's better. They don't. And so you really will get educated very quickly into how difficult it is to introduce new technologies, new techniques, new ways of thinking into organizations. So the first step, though, before we get into the top 5 ways, is we got to do some level checking, because I always say you can't introduce model-based X unless people are using X. So the one mistake I've seen is that if you start talking to people that aren't doing systems engineering about model-based system engineering, you just got too far of a bridge to cross. And it's easy to get confused because a lot of times people say they're doing systems engineering and they're really not. And we're going to talk about what it means to do systems engineering in a minute. But systems engineering is the discipline. And then model-based systems engineering is a methodology on top of that discipline that has its own process that's embedded in its modeling languages and tools that are used. And notice that you really follow that pyramid up. You don't start at the top and work your way down. You start at the base and make sure that's solid and work your way up. That's why we use the model of a pyramid. So first step, are people using systems engineering at your organization? Here's some things that you can check to be sure. So to me, the most important one is on the right there, right? Has your organization really internalized the relationship between the investment in systems engineering, not model-based, just systems engineering, and project cost time savings? There are decades of studies that show that if you put in, say, 5 to 10% of your project budget into systems engineering, you will actually save significant amounts of time and money on the back end. And that's what basically this graph is showing you. At some point, it's diminishing returns. It doesn't help you. But if you're in that, say, 7 to 10% range or 7 to 12% range, you're going to get benefit. And the question is, does your organization really understand it? Do they believe it? Have they committed to it? Because if they haven't, again, it's going to be trouble selling MBSE. Another one is, our requirements identified, tracked, and allocated? Because if they're not, that's sort of the starting point for most systems engineering. If people are just sort of developing systems and not worrying about what the requirements are, again, then they're not really using systems engineering. They probably need sort of a level set sort of organization change to adopt that. Are concepts developed and analyzed before detailed design is started? And that's related to number 4. That's number 3. Number 4, at the same, this pressure to just do something as opposed to, well, stop and think about it for a minute. So this idea of starting with concepts and doing some analysis before you jump into detailed design is, again, part of that systems engineering V that I showed you earlier. Now, at the same time, you can't have analysis paralysis. You can't stay in the concept stage forever. You have to still move to detailed design. So does the organization know how to make that happen? And lastly, is there an engineering process in place? So is there some sort of stage gate system, an agile system, whatever it is? Is there something that a process that takes products from concept to market that then builds in systems engineering? So at the milestone reviews, are people asking to say, hey, did we do our systems analysis up front? Have we generated the artifacts that we think we need to show that we're moving in the right direction? So again, these are all things that help reinforce that use of systems engineering at the company to make sure it's a place that you now have that base of knowledge and expertise that you can build on. Now, once you've got that, if you say, okay, I've got enough system engineering in place that I can build on it, now you're going to introduce MBSE. And again, it's not like, oh, you're just going to get people to sign up to take a training class and then they're off and running. This really is a change in the way people think about how they work. Even if you're doing systems engineering, probably doing it in the sort of traditional document-based way, MBSE really is a paradigm shift, and you have to treat it as such. So this is a change leadership model. It comes from Cotter. It's been around for decades. This is the latest version of it. And there's a few steps in here you'll see, and I'm not going to go through all of them, but basically, what's that burning platform that's going to drive people to change? Who's that guiding group that's going to make sure things are moving in the right direction? How do you enable people? Do you need training? Do you need support? How do you support them as they move through this? How do you help people understand that it's going to be a journey? Things are going to get harder probably before they get easier, why it's worthwhile, why it's going to be better and worthwhile doing at the end. And one of the most important steps here is the short-term wins step, because if you tell people that we're going to go on this journey and it's going to be 3 years before we see any benefit, no one's going to go. They just say it's not worth it. Why would I keep doing it? Or you'll get partway there and the pain will just be too great. So part of your plan has to involve showing benefit very quickly with these MBSE approaches. And that's what we're really going to talk about. Now, the top 5 really are your ways to get some quick wins. And there's sort of a setup for this, because again, I'm saying that you've got you as the MBSE leader or evangelist or person that's interested, or the people who have been told to do this, you've got to be willing to put your skin in the game of the project team, right? Your job isn't to say to the project team, okay, you should go do MBSE, it's really good for you, good luck, figure it out. You've got to be willing to put some work in. So for these top 5 to work, these are based around the idea that the MBSE leader, you, the evangelist, has saying, okay, I want to put skin in the project team's game. I'm going to help. What can I do? What can I suggest they do? And so we created this in a way that we said the project teams will see immediate value. You have one MBSE lead that can use existing information. You don't have to stand up a whole MBSE core team and then pull the project team into a whole bunch of meetings to figure out how to get the information you need to do what you have to do. You can start with what you have. It's tool agnostic. You don't really need a tool beyond your basic drawing, word processor, spreadsheet tools. If you have a tool, okay, but again, you don't have to have it. It's scalable and flexible. Again, it starts with whatever you got. If you can start at the system level, okay. If it's a subsystem of a larger system, and that's the better place to start because it's more fertile ground, the team that's doing the subsystem is more interested in using these tools and approaches, fine, start at that level. And it also, information that you have or can easily get. We're trying to say at whatever phase the project is in. That's what we're saying, that these kind of say, well, maybe you're at the front end of the project and you want some tools that help you do concepting. Maybe it's at the back end of the project and they're now checking to make sure the product is passing its tests and meeting its verification and validation tests, or they need help saying, well, what's the final set of acceptance tests that the customer is going to use? So you can use these tools in a lot of different ways, or these top 5 ways to get started. And overall, it fits our philosophy, which is the best way to get started is to start to do something. You don't have to spend a lot of time analyzing and synthesizing and thinking if you start with these top 5. And the way we're going to go after these and explain them is we've got a mix of methodologies and models, because again, we think that the best way to get started with modeling is to start modeling, because what you're really trying to do here is understand your organizational requirements for the methodology, and by extension, what tools you may want to start using. We don't think we have to be very dogmatic about which diagram, using the perfect SysML diagram with the perfect syntax. It's much, much more important to figure out how MBSE is going to bring value to your organization. So the way we're going to talk about these is we're going to talk about each of the top 5. We're going to explain why it's useful and why we chose it, and then what does it look like and how to visualize it. Important point about the top 5 that I'm going to show you here is that they don't have to be done in order. They do reinforce each other. These aren't in priority order. You can pick on where your organization pain point is. So you should feel like, again, you have complete freedom as to which one you want to start with, how much of it you want to do, how deep you want to go. That's all got to be by your judgment based on, again, finding where that value is for your business. So we're going to start with the first one. And this really is one of my favorites, frankly, is creating a system architecture document. And the first question is, well, why is that useful? And for me, it's really documenting the system architecture. There's lots of documents that go into the detailed design and subsystems and components and budgets and plans and all that. But I don't always see a higher level view of, well, what are the drivers for this system? Not every requirement. And notice it's not a requirements document. It's really, what are the things that drove the architectural decisions, right? What are the key things that made us pick what we picked? Give an overview of the architecture that was selected and some relevant views of that architecture. So we're trying to provide people a view of the system structure, key behaviors, and how these components actually meet the requirements. Again, going back to what Dave Oliver said, specify what you want or take what you get. This is what I call a forest document as opposed to a trees document. It provides a foundation that you're going to give to other people that they can use now to figure out things like what's the risk, what's the cost, what's the schedule, how do we do work breakdown structures, right? The architecture helps drive which teams do what. It helps support how you're going to analyze and verify it. And also it helps minimize the risk that you haven't made the right architectural decision and ensure that you haven't lost why you made the choices that you did. Now let's talk about what it looks like. So on the left, I've got sort of a general outline that you can't really go wrong with. It's got an introduction. It says, okay, what is the purpose of this system that we're developing in this document? I'm sorry, it's the purpose of the document and what is the revision history of the document. Then you go into the system, right? General overview. What were the assumptions? What were the constraints? Again, it references but does not duplicate the requirements document. It's not meant to be a requirements document. It's really meant to capture things like assumptions, constraints, key design considerations, and those high-level mission profiles and scenarios that the system is supposed to achieve. So now you start seeing the use of some of the diagrams, right? You can capture a profile in a picture. You can capture it in a sequence diagram. Another important part is what environment does the system operate in, and what are the interfaces? And that's captured in a context model. And it's not just the environment interfaces in operation. You have to think about the life cycle of this product. You have to think about the environment that it's being manufactured and assembled in. You have to think about operation. You have to think about maintenance. You have to think about decommissioning. So again, it's that higher level view of when you're really thinking about the system and its life cycle and what does it see in terms of the things around it. Then you capture that system architecture, and usually it's going to be some sort of block diagram, some kind of structure model. You're going to capture key attributes, and then whatever other information you find useful. Note the heavy use of models versus text. The key here is that since again you're the MBSE leader, you is the one generating this document. That's how you make sure you have consistency, right? So if you had a bunch of different people do this without, again, some kind of tool, you're going to have trouble. But again, the top 5 is not about you're starting this journey, you're trying to find places to add value. You are the person who's driving this. So you're going to make sure that all these models are consistent with each other as you're using them. If you have a tool that you can use to help with that, great. But if you don't, it can be your brain to make sure that everything aligns. Moving on, interface control models. So we already kind of talked about this, right? Again, you've got these great models of a system. It lets you do completeness and consistency checks very visually. Again, if you have a text document, not clear how you do that. And you're showing the subsystems, the interfaces, and the data exchanges. And what does it look like? It looks like just like we said, right? Basically, it's an interface control document with the models included. Now, this isn't fully MBSE, right? We'd rather have that underlying model and generate the interface control document out of that. But again, this is where to start. So if you're more like a traditional system engineering company, you've probably got some text ICD, that's the master. What we're saying here is find ways to add some models into that document and start aligning the things in the document with the diagram, because you know it'll be better for people if they start thinking and using some of these diagrams to understand the interface. The next one, capturing operational scenarios as validation tests. Why is this useful? Well, ultimately, every system has to meet the needs of its users. Those are the stakeholders or end users. It's the user acceptance testing. And the way you capture those is operational scenarios, which are really a little more detailed versions of the mission profiles. And I'm going to show you, there's a couple of examples here I give you of the mission profiles. The first one is from Virgin Galactic. This is a space tourism where this vehicle is launched out of its mother aircraft. It goes up into space, provides passengers a view of some experience of weightlessness for a few minutes, and then lands back on Earth. But these profiles have been around since before the space shuttle. And I have a space shuttle example where this is the space shuttle taking off, doing its mission and landing, but also if there's an abort in the middle. So again, these mission profiles are these high-level views of what the system has to accomplish and what the user, right, or the person who asked for the system is expecting it to do when it's delivered. And you need to consider nominal profile, failure, startup, maintenance, all the things across that life cycle again. And the way to capture it usually will be some kind of sequence diagram where the system being designed is basically one sort of column in that diagram, and then all the things that interface with that system in the course of its mission are captured, and then you start looking at the interactions. It might look like a sequence diagram, maybe it's a swim lane, maybe it's a functional flow diagram, but the key is that the system being designed is captured as a single entity. You're not breaking it down yet into subsystems and components. And you're looking at the things that interact with the system. So again, the system of interest is a black box that interacts with these other entities, and you're capturing the different scenarios that this system's going to see. Again, from a design standpoint, but then also from a validation standpoint. Very powerful. And again, why would you want to try to capture this in terms of a text document when a diagram is so much more clear and effective? Another way, linking test plans to system structure. Everybody knows that you have to connect your test plans to requirements, especially doing validation and verification. But there's another view that we can take. If we have a system structure, just a hierarchy like we've got here on the right, we've got our spaceship, it's got 8 subsystems, and we've taken the propulsion subsystem and broken that down into 3 subsystems. And what we've done now is say, okay, now suppose there is a set of tests that we've run, and some of the tests have passed, some of the tests have failed. If you're thinking from a requirement standpoint, you go, well, let's assume that every test is mapped to a requirement. You say, well, I've passed 60% of my tests. I've got 5 tests, 3 passed, 2 failed, 60% passed. And that's useful information. It gives you an idea of where you are as far as getting the system done. But also, this view would let you say, hey, out of the 8 subsystems, 2 have passed, 1 has failed, and 5 have not been tested at all yet. And that's your bird's eye view of the system status based on verification and validation testing. And the way we'd say visualize this is you can draw it out where you take your structure model and simply add on the test plans for each subsystem, but also better captured as a spreadsheet or a database now, where you've got your subsystem on the left, you know, your test number or numbers, and then the status. And once you have that, you can then generate any kind of report that you want. You can even, in theory, generate a drawing out of that. And number 5, very powerful, the allocation of key parameters in a structure model. So let's say that critical attributes are usually presented in tables and captured in analyses, but we think it's very useful to show the allocation of these parameters to the subsystems and components because you get more insights that are useful in the analysis and synthesis of system architecture. One example is mass, right? So if you say, okay, a rocket has to weigh whatever 1,000 pounds, and now you've got to break that out because each subsystem then has to make sure when it's done, it adds up to the 1,000. So you've got to allocate that out. Another is, let's take a quadcopter example, where you've got the thrust equation that relates the motor and the motor RPM and the propeller diameter and the number of propellers to how much thrust the quadcopter can generate, which goes directly to how much weight it can lift and how long it can fly. But they don't tell you how to make trade-offs between those components, right? Because when you're trying to achieve a certain thrust, should you do it with a larger propeller or a faster motor? And what does that do for weight? So by capturing these equations and parameters, we can give the subsystem and component designers some constraints and guidance. And the way we do this is we go back to our structure model, and again, we add these equations and the parameters as information tied to the structure model. So in this case, you can see the mass. We know the equation for mass, sum of mass equals the total mass. We've got each of the subsystem masses now are given as parameters for each of the subsystems in the hierarchy. And then the thrust equation is made up of these parameters that includes propeller diameter, propeller constant, power factor, motor, etc. And we allocate those. In this case, we've said that the propeller is considered to be part of the structure system, but the motors are part of the propulsion system. So the RPM really belongs in the propulsion, and the rest of those parameters really go in the structure subsystem. And so this raises a really interesting question, because now if you're trying to say I want to achieve a certain thrust, you've got these two subsystems that are given the parameters they have to meet, and in order to figure out what the trade-offs are, they have to work together. And this helps you start to understand how these subsystems have to interact with each other to achieve, again, the overall system goal. This is interesting because unlike the other things that we just showed, the other top four, this one, just generating this artifact is as useful as the result. So you learn a lot just by someone presenting this to you, but even in creating it, figuring out what are those key equations driving your system design, thinking about the allocation of those to subsystems, because someone might say, well, gee, why is the motor part of the propulsion system? I want to be part of the structure. That way the structure team can handle all of the thrust issues, right? That'd be an interesting conversation to have as you're developing this diagram and allocating things. So again, I'd say I find this one very powerful from the sense that the process is just as important as the outcome. So now we've made it through all the top five. So what's left to do? Well, like we said before, there's still a lot left to do, because remember, we've got this whole change, leadership, organizational change process that we've got to go through to really get people using MBSE the way it's meant to be used. We've got to build the benefits case. We've got to pick a methodology and process and eventually a tool. We got to hire and train resources. We got to find allies, make sure those allies have a vision. We got to make sure we get our short-term goals. And then we got to build MBSE into all the existing work processes so that it becomes the way people really work. So what the top five get you is basically the feedback and the goodwill that you need to do these other steps. And there's a bunch of sort of pitfalls that you want to avoid, though, as you're doing this. There's always a tendency to boil the ocean, that everything everywhere all at once, where, well, if I do a little bit of MBSE, it's got to be good, it's all or nothing. Let's do MBSE everywhere. You shouldn't do that. Try to start somewhere where you can get those quick wins. Start small, get the benefits, and build up. Again, don't start with the tool. A fool with a tool is still a fool. It doesn't tell you anything about process and benefits. Sometimes people think that the answer, model-based system engineering, means you model everything down to the lowest level, and you're not done until you've got a component-based hierarchy that goes down to every bolt, nut, and screw, and you've got parameter models and behavior models that go down to the level. Not true. You have to model to the levels that get you business value. And ultimately, the map isn't the territory. A system is complicated. It's so complicated that you're not going to capture it in any one model or in even any N models. You really have to think hard about the modeling that you want to do. And this is probably one of the biggest issues that people have when they introduce MBSE. They try to think that, well, the goal here is to make sure we've got all these models and they're all connected. And they spend so much time doing that that they never figure out, well, what was the value? And again, the value is the last thing, right? If you don't ever deliver value, you're never going to get anywhere with this. And you have to think about people. They're like, sooner or later, they want to know, what do we get out of this? Show me the money. So just to summarize again, MBSE is an organizational change process, requires change leadership. You definitely need system engineering to be present to some extent as a prerequisite. And the top 5 ways to get started are the quick wins that you need to get momentum. And with that, we're going to go to questions.
Thank you for everyone for attending. Make sure to follow us on social media and subscribe to our YouTube channel where you'll be able to see all of our content and sessions uploaded. And looking forward to see all of you in a future session. Thank you.